All right, Riley, I'm going to start the timer here. Like I said, you'll have 10 minutes. We will have some extra time at the very end for questions. So I know that you said you might end a little bit early. We can certainly take some of your 10 minutes to answer questions. But if not, we will have time at the end. We had one cancellation today. Matt, who was right after you, actually canceled. So we'll be running a little bit ahead of schedule. So at the end, we can have some time for extra questions if needed.
Okay.
I'll go ahead and start the timer for you. And then whenever you're ready.
All right. Hi, my name is Riley Alpuche. I am a PhD student in Dr. Lednev's lab over in the chemistry department. Today, I'll be presenting my work on determining the limit of detection for a universal body fluid identification method that our lab has previously developed. So in forensics, a DNA profile can be created with as little as 50 picograms of DNA. Body fluids of interest for forensic investigators include semen, sweat, saliva, vaginal fluid. Not listed also includes urine. So the necessary volume of body fluid for 50 picograms of DNA is actually quite small. And our lab has developed a method that, using Raman spectroscopy, can detect and correctly classify these body fluids of interest as what they are. We don't know how sensitive it is, however. If the little volume required for 50 picograms is something that we can actually accurately detect. So a little background on Raman spectroscopy. It is a form of vibrational spectroscopy where we use a monochromatic light, a laser that is set to one specific wavelength to irradiate a sample, which then it excites the sample, and then it comes down from this excited state. The molecules inside, they're excited, and then they come down to a ground state. And then from this, we can measure a difference in polarizability, which is the difference in how the electrons move in the outer ring of the molecules, creating what's called a Raman shift. And that is ultimately what produces our spectra that you can kind of see here. So this is the Raman spectrometer that I use specifically. However, for this limit of detection, I need to be able to deposit very small samples from the average concentration of DNA in these body fluids of interest. The calculated volume necessary for 50 picograms of DNA is quite small. A micropipette that's typically used in the lab can deposit only as little, like at the smallest, 0.5 microliters. That's not a lot. It's 500 nanoliters, but compared to this, it's significantly lower or higher than these nanoliter measurements. So that's where an instrument over on the SUNY Poly campus kind of comes in. The Cyflex Arrayer S3. It uses piezoelectricity, which is a type of electricity that comes when you apply a force to a sample. It applying that force then creates the electricity, and this electric field will deform the sample to create a droplet or to control the displacement to create very, very small droplets. These droplets can actually be deposited as low as 300 picoliters. On average, they're between 300 and 360 picoliters. I have here 300 picoliters is 0.3 nanoliters, which is a lot closer to what we have listed as necessary for creating a genetic profile. The way I do my sample preparation is first, using a 96 well plate, will load up my sample into the Cyflex Arrayer S3, and it will deposit onto a microscope slide that looks something like this. Each slide is labeled with the body fluid, the donor code so that I can keep those separated, the date that it's prepared, and then of course my initials. So you can see here that each slide is prepared with 10 drops, 5 drops, and 1 drop of the body fluid that we're looking into. For here specifically today, I will be talking about saliva from here on out. So this is again for between 300 and 360 picoliters, 1500 to, oh, I can't remember this high end of this one, picoliters, and then 3000 to 3600 picoliters. After this sample is deposited and dried, I put it onto this stage here, and using the 100 times objective lens, I can find the droplet. It's very difficult. They're very small. Find the droplet and analyze it. Hit it with my laser, collect some data regarding how the molecule is vibrating, and then it spits out a cute little spectra for me. So here we can see a difference between normal saliva and filtered saliva, as well as each of the different droplet sizes. I put filtered saliva on here because the piezo dispense capillary, the part that actually spits out the droplets, is it's a very thin opening and it very easily clogs. So we have to filter the sample to make sure there's no skin cells or anything that could risk clogging it. And then of course I have to make sure that that is still recognizable by our method. Otherwise, what even is the point of using this thing where it's not going to measure? So we can see here the classification of my droplets that I have collected. We can see that the 1 drop of saliva was entirely classified as saliva. 5 drops of saliva, again, entirely classified. And then 10 drops, we had 2 that were misclassified. Upon looking at their spectra, they were a little different. You could consider them outliers, but because I included them here, I can't really get rid of them because that's science. So this shows that our method can identify saliva as saliva in samples as low as 300 picoliters. That's 0.3 nanoliters. And if we look at saliva, we only need 1.5 nanoliters to create a full DNA profile for forensics. Now, granted, these numbers come from relatively fresh samples that have not degraded. So you likely need more for samples that have degraded, some that are older, that have withstood the test of time and the environment and all of that. But from here, we can see that our method is so sensitive, so effective, that if there is enough for a forensic investigator to create a genetic profile, then we can identify it. We can say that this is here and this is specifically saliva. So future steps regarding this work is to deposit different droplets of body fluids. So for example, sweat, vaginal fluid, and semen, and then analyze it on our Raman instrumentation and determine whether our method is effective in characterizing those samples as well. That is really all I have. Are there any questions? We have about 2 minutes.
All right, thank you so much, Riley. If there's no questions, then you are all set.
Okay, well, then that's fine.
Thanks so much.
Mhm.
All right, so I had mentioned that our second presenter today, Matthew, had canceled. We have about 10 minutes here. We can certainly keep going. Third on our list is Peng Hao. Am I saying that right? I thought I saw you here.
Yeah, it's right. Okay, I can share my screen. Yeah.
Yeah, go ahead, share your screen, get yourself set. So
Okay.
Yep, go ahead. We have a timer going today, so you will have 10 minutes. You'll see the timer ticking down on my screen. You'll hear it at the end of the 10 minutes. You can use the 10 minutes however you would like. If you want to reserve some of that time for questions, you certainly can. If not, we'll have time at the end since we are going to run a little short today. So whenever you're ready, go ahead.
Okay. So good afternoon, everyone. So today I want to introduce our project. This name is called Enhancing Human-Robot Collaboration Through Silent Speech Interfaces. So first, I want to introduce you some background of this project. So this project is help for some patients with voice disorders. This kind of patients cannot speak anything. So we want to try get some signals from the facial skin, so we can convert this kind of facial skin to speech. As you can see in this figure, when the people try to speak, there should be some motion of the facial skin. Also, we call it biopotential. We can collect some biopotential. This kind of method is called electromicron. It's also the abbreviation is called EMG. So we believe this EMG exhibit a strong correlation with the content of silent speech. Also, for this one, we want to apply this kind of silent speech interface to human-robot collaborations. This is the background. So secondly, I want to introduce the scenario we want to apply this kind of technology. As you can see in this figure, there are two subjects, subject 1, subject 2, sitting in front of the desk. They try to assemble and disassemble the computer components. As you can see here, there are two computers, one desktop and one laptop. And there's also a robot arm. So the basic idea is this two subject can speak something silently, speak the command silently, and our silent speech interface can collect some signals from these two subjects, and we convert this kind of signals. You can see here, this is called EMG signals. Convert this kind of signals to command, and this kind of command can transfer to the robot arm, robot arm. So this robot arm can do corresponding operations, like you can grab some components parts to this subject. To finish this, we also want to use this kind of signals to do speaker classifications, because we need to know which one is speaking. And if we just identify the speaker 1 is speaking, so we know the locations of the subject 1. So next step is a keyword classification. For example, if the subject 1 speak screwdriver silently, this robot arm will try to take the screwdriver to subject 1. And another thing very important, because the robot arm need to know the location of the human hands, because the robot arm need to hand on the screwdriver to the hand. So we also put a motion capture marker on the hand to capture the hand movement. So in this way, the robot arm can know where the hand is. So next part is about the sensor fabrication. Actually, this is the process how we fabricate the silent speech interfaces. As you can see, you can see here. So basically, we use many materials, soft materials. The functional material is very simple. It's just a sodium chloride. It's and we mix the sodium chloride with some solvent like ethylene glycol and DI water. We use some drop casting and pattern method to fabricate the final product. This figure, you can see the final product here. You can see this is the electrode array. It's transparent, and we can connect this kind of electrode array to a circuit. This circuit is a wider circuit. We can just transfer the data to the computer wirelessly use Bluetooth. You can see here, it can be put into the chest pocket, and this figure shows what it looks like when we attach this kind of interface to human facial skin. So here is the final silent speech. You can see here the electrode array is connected by the cables to this circuit board. And using this device, we can just collect some signals, something showing here in this figure. So you can see here, for example, this is a two words, bottom case, and this is a word, CPU. You can see the pattern, there are different patterns for the two different commands. So we try to develop some algorithms to classify this kind of commands. Also, for different person, the signal should be different. For example, for subject 1 and subject 2, because each person have different muscles, the amplitude of the muscle of the signal is different. So we want to classify the speaker in this way. So next thing is about algorithms. We use some machine learning method. This machine learning method is called temporal convolutional network. So we use this kind of network to do the classifications for speakers and keywords. The basic idea is very simple. We just do some pre-processing of this kind of signals. We just cut this kind of signals into very, very small pieces. Like each piece is about 0.15 seconds long. And you can see here is window 1, window 2, window 3. Then we just calculate some features of this kind of data. We use 3 features here. The first one is the root mean square. Second one is Wilson amplitude and zeros crossing. Also, there's another many other features, but we just select this 3. It's enough for us to do very accurate classification. So then we put this kind of features into the machine learning method, machine learning model. Then we finish the whole process for speaker classification and command classification. Okay. Finally, we just do demonstration in the human-robot collaboration. As you can see here, there are 2 operators, operator 1 and operator 2. We attach the developed silent speech interfaces on the facial skin. So, for example, when we try to speak something, this robot arm will sense what we are speaking. So then, so the robotic arm will perform the corresponding motions. And as you can see here, this is the infrared cameras. As I said before, the infrared cameras can capture the motion of the human's hand. So in this way, we know the position of the human hand. So the robot arm know where should the computer component should be delivered. As you can see here, this I can grasp some components to the operator 1, and this is this row is for the assembling of the desktop, and this row is for the disassembling of the desktop, and this last row is about 2 operators working together and to finish the whole process. One is for desktop, one is for laptop. Finally, I want to make a conclusion of our work and the future work. And for this project, we just develop 1 silent speech interfaces and make a demonstration for the application in human-robot collaboration. And in the future, we want to do some phonemes level silent speech recognition, because you can see here, this words level, we just classify different words. We want to extend this research to phonemes level. In this way, we can reconstruct the new words based on the knowing phonemes. So in this way, it makes this project more comprehensive. Lastly, I want to thank the NSF for the financial support. So that's it. That's my presentation. So any questions?
All right, if there's no questions, thank you so much. You're all set.
Okay.
All right, so next up we have Julia. Julia, I saw that you're here. We are running a little bit ahead of schedule. Are you ready to go?
I am ready.
All right, so you will have 10 minutes here. I'll start the timer and you are all set. Go ahead whenever you're ready.
Okay, let me share my screen. Okay. Does that look okay? I don't know if anyone can see that.
I can see it now. Yep, so you're good to go. I'll start
Okay.
the timer here and you are all set.
Thank you. Okay. Good afternoon. My name is Julia Drummond, and I'm going to talk to you about a pretty small scale study that I conducted during my graduate career in public health at SUNY Brockport. My study investigated the public perception of recycling to determine the motivations behind the participation or lack thereof in recycling behavior. And I want to thank my faculty advisor, Dr. Antwi, for allowing me to conduct my study and present my findings. Let me zoom in a little. So why investigate recycling? Recycling is a critical component of combating the climate crisis that we're currently facing. But as we know, to be able to investigate recycling as researchers, we must first define it. Therefore, for the sake of this study, appropriate recycling behavior was defined as the recycling of proper reusable materials in ways that adhere to local, state, and federal guidelines. These guidelines often detail not only the types of acceptable materials, but also the levels of acceptable quote unquote contamination. Contamination refers to any organic substance, such as food or beverage residue, that remains in or on the object when it's disposed of. So, just as an example, a pizza box is considered recyclable, but if it's entirely soaked in grease, it's often no longer considered acceptable in most jurisdictions and must be thrown in the garbage. Different jurisdictions will often accept varying degrees of contamination. So Erie County recycling companies might require the box to have very minimal amounts of grease, while Monroe County allows nearly 50% of the box to be affected by greasy residue and still be recyclable. However, this also opens a new debate surrounding the terminology that companies use to describe the various levels of contamination. Most descriptions are vague and easily misinterpreted, but for this study, that's neither here nor there. Past research has demonstrated that public health officials need more information regarding people's perceptions of the climate crisis before designing effective interventions. A handful of studies have attempted to highlight common and primary perceptions, but they've struggled to do so. A more recent study from 2021 concluded that effective interventions can only be implemented once there's an understanding of people's motives and perceptions of recycling. With all that being said, my study was designed to identify public perception of benefits and barriers to participating in appropriate recycling behavior. The data used to assess public perception was collected through semi-structured interviews with a convenience sample of 17 participants. They were recruited via word of mouth, came from various backgrounds. Participant age ranged from 19 to 52, with the majority of respondents being in their early 20s and a median age of 22 years old. Interviews were audio recorded and transcribed to ensure credibility. The interview questions mainly focused on recycling, but they also touched on some broader environmental concepts, which we included these broader topics for the sake of understanding motivations behind people's perceptions. So, for example, participants were asked about their perceptions of global warming and whether or not we are in the midst of a climate crisis. 12 out of 17 participants, or 71%, report believing that the climate crisis truly does pose a threat to us and is not simply a fear tactic. One participant reports believing that the climate crisis is not a threat, which made up 0.06% of our sample, while the remaining 4 participants, or 24%, report feeling unsure about the matter. In a similar vein, participants were asked about the impact that they believe they have on the environment. 82% of participants, or 14 out of the 17, believe that their actions directly impact the environment, while still acknowledging that corporations and industries have a more significant impact than individuals. As an outlier, one individual stated that they feel as though their decisions and behaviors do not have any impact on the environment whatsoever. Moving towards the recycling focus questions, participants were first asked to gauge their confidence in their own ability to appropriately recycle, and a content analysis of the responses revealed that most participants, or 12 out of 17 to be exact, which is 71% again, report feeling confident in their ability to appropriately recycle, while 2 feel only somewhat confident and 3 don't feel confident at all. 13 participants, or 76%, report believing that recycling is sometimes or always convenient. The remaining 4 participants, or 24% of the sample, consider recycling to be primarily inconvenient. One of these 4 respondents elaborated by saying that it is always easier to toss everything in garbage bins. And lastly, 2 significant barriers to recycling emerged, suggesting that they may be some of the most influential factors. The first barrier is a lack of knowledge regarding what can and cannot be recycled. Some specifically mentioned not knowing or understanding which items are accepted in each jurisdiction. And the second and most commonly reported barrier is that the people surrounding the participant do not participate in recycling themselves, with 30% of the total sample volunteering this information. And moving right along to the conclusion section, I found the 2 main barriers that emerged from participant responses to be quite surprising. I anticipated that self-efficacy would be a main barrier to recycling just based on past research findings, but our participants revealed otherwise. Instead of a lack of self-efficacy, there was a lack of education or knowledge preventing participants from participating in appropriate recycling behavior. Additionally, I did expect peer behavior to be influential, but didn't anticipate that factor to be the most common response when asking participants which barriers impacted them the most. It was concluded that individuals need help determining which items are acceptable for recycling in different jurisdictions, since it often varies from one county to the next. It's recommended that more clear communication be developed between waste or recycling companies and their respective constituents. This communication, just as an example, could come in the form of a pamphlet that companies mail out for homeowners to keep on hand, or even an interactive website that allows those who are particularly conscious of recycling to visit and get answers about the items that they're trying to dispose of. People would also benefit from more widespread educational content promoting appropriate recycling behavior. This could come as eye-catching visuals on posters in food-centered areas such as food courts or cafeterias. Signage like this would assist those who aren't as confident in their recycling ability. Overall, it was determined that further research with similar objectives be performed on a much larger scale. These studies would offer significant insights into practical interventions that encourage people to recycle more. For example, a college-wide study that assesses perceptions via focus groups or an online survey would allow for a more prominent and representative sample. Results from these studies could inform future studies regarding the most effective interventions for encouraging recycling. And that's all I have today. So I'd be happy to answer any questions that anyone might have. Thank you for listening.
All right, if there's no questions, you are all set. Thank you.
Thank you.
So next up we have Stephanie. Stephanie, are you ready to go? I know that we're still a little bit ahead of schedule.
Hi, yeah, I'm good to go.
Okay, if you want to get your screen shared and get yourself set up, I will get the timer going.
Right. 2.
All right, I can see your screen, so I will start the timer here and you are ready to go whenever you're ready.
Perfect. Okay. Where's my laser pointer? Sorry, I'm new to this, so. Okay. All right, so my name is Stephanie. I am in the clinical psychology master's program with a research emphasis at SUNY Brockport. Today I will be talking about my master's thesis proposal, of which is about age and impulsivity with death anxiety and other underlying factors. So it begins with the terror management theory by Greenberg et al., which posits that mortality salience and death anxiety are positively correlated with one another. Death anxiety, which can be defined as Anxiety and or terror resulting from thoughts and reminders of death has been shown to be negatively correlated with age. Both men and women seem to peak in death anxiety in their 20s, but then women have a second smaller peak in their 50s. So since there is no direct research that has been found between death anxiety and impulsivity, I use mortality salience as a way to anticipate the relationship between the two instead. Mortality salience conditioning is when thoughts of one's own death are induced by conditioning or other reminders that death is inevitable. Mortality salience has been shown to increase aspects of impulsivity like risk-taking and delay discounting. Impulsivity and risk-taking have also been shown to decrease with age. And then based on the terror management theory, self-esteem is also involved with how people react to death anxiety in regard to their impulsive behavior afterwards. Death acceptance, which is how accepting one is in regard to the inevitability of death, has been shown to be negatively correlated with death anxiety as well. So the aim of the current study is to investigate the underlying factors between age and impulsivity. We are looking to see if death anxiety significantly mediates the relationship between age and impulsivity, and to see if death acceptance will moderate the A path and if self-esteem will moderate the B path. So this is just the A path right here, down here, and then the B path is right here. All right, so our sample will be taken from Prolific, which is an online survey platform. It will consist of 300 adults among 5 different age groups, which will be 20 to 29, 30 to 39, 40 to 49, 50 to 59, and 60 and over. We will only be looking at men and women in order to ensure that we have the women in their 50s to incorporate the finding that they have a second peak in death anxiety in their 50s. Our measures include a background questionnaire, the death anxiety scale, which measures death anxiety, the UPPSP impulsive behavior scale, which measures different aspects of impulsivity, the 5-trial 1-minute delay discounting task, which also measures delay discounting, which is another measure of impulsivity, the death attitude profile revised to measure death acceptance, and the Rosenberg self-esteem scale. Our analyses will be conducted in IMB SPSS software, and Pearson correlations will be used to investigate the correlation between death anxiety and the 2 impulsivity measures of the UPPSP and the 5-trial 1-minute delay discounting task. Models 4 and 12. So model 4 would just be this initial mediation, which is age, death anxiety, and impulsivity. And then model 21 is the entire thing. From Hayes's process will be used to conduct the initial mediation and the moderated mediation. So for our anticipated results, we anticipate that death anxiety will be positively correlated with impulsivity. Regarding the mediation, we hypothesize that older adults will have lower impulsivity via lower death anxiety, with a significant positive association on the B path, and negative associations on the A path, the C path, which is the direct path as well, and the overall indirect path, which is all 3 of them combined. And then regarding the moderated mediation, we anticipate that low death acceptance and high self-esteem would have a significant positive impact on the mediation, significantly moderating the relationship between age, death anxiety, and impulsivity. This research is important for further understanding of the relationship between age and impulsivity, as well as further investigating what happens as people age, which this can actually tend to be an intimidating topic. If the findings in the current study are significant, this will hopefully prompt further research into the underlying factors that may be potential mediators and covariates in the relationship between age and impulsivity, like potentially different aspects of memory, physical fitness, and other factors that may be impacted by age. And that is all I have for you today. Any questions? All right.
So thank you so much. You're all set.
Yeah.
All right, up next we have Jake. Jake, I saw that you're here. If you are ready.
I am. So there's actually 4 of us. We're all representing a class for this poster. We're going to have Lizzie share her screen, and if anybody in the chat would like a copy of our poster to look at closer, we also have a PDF of that we can share.
Sounds good. And so it looks like all of you are here. Is that right?
Yes.
Okay. All right. I will start the timer here, and whenever you're ready.
Hello, we are all students at the Cooperstown Graduate Program in Museum Studies through SUNY Oneonta. In our Historic Preservation class this semester, we worked closely with Otsego 2000 for the 25th anniversary of the nomination of the Glimmerglass Historic District. The Glimmerglass Historic District is defined by the area around Otsego Lake. It was named significant by the National Park Service due to its association with the Cooper family, literature, recreation, natural beauty, and so much more. Almost 1,500 buildings, objects, sites, and structures contribute to the district, all of which were constructed between 1746 and 1949. Due to guidelines set by the National Park Service, this area, called the Period of Significance, tends to end, at least 50 years before a historic district is nominated. With some exceptions, this is done to evaluate the historical significance of said area.
So local organizations and residents nominated the Glimmerglass Historic District through an extensive process. The process requires significant historical research, documentation, and public comment for any objections. If a majority of property owners object the nomination, the area cannot be listed as a historic district. The Glimmerglass Historic District received its designation in 1999. The district experiences many benefits from its designation, such as employment opportunities, tourism, sustainability, and tax credits.
Our first myth is that historic preservation is expensive. In New York State, as in many other states, owner-occupied and residential historic houses are eligible for up to a 20% state tax credit on historic preservation work if at least 5 to 10% of that work is exterior. These tax credits roll over year to year until they are used up, and in some cases, they can be received as cashback. The easiest way to know if your house qualifies is if it is listed on the National Register or part of a National Register historic district, such as the Glimmerglass Historic District. Commercial or income-producing properties can receive an additional 20 to 30% federal tax credit on top of the state tax credits. Otsego 2000 assists with every step of this process in the Glimmerglass Historic District and in Otsego County more broadly, which is why Otsego County, which is where SUNY Oneonta and Cooperstown are, is ranked fifth in the state for historic preservation tax credit usage. Nonprofits may qualify for grant funding to undertake historic preservation work, such as from the EPA. And the Preservation League of New York cites studies that show that historic designation increases property values by up to 35% per decade, which makes preservation a long-term investment.
Our second myth for this project is people tend to think that they can't do what they want with their properties. Designation with the National Register of Historic Places is an important planning tool for federal and state governments to preserve the American historic and archaeological resources. Individual property owners that do not use federal or state resources like funds permits or licenses to maintain their buildings have permission to change them. This can include anything from window replacement or additions to their existing structures. With that being said, structures with historical designation can only change so much without challenging a certain level of integrity or character. The Village of Cooperstown is one of the many municipalities that has created a system with more requirements for private property owners to prevent any changes that would challenge the district's integrity. The Historic Preservation Architectural Review Board meets monthly to approve specific projects done within the district limits.
Our final myth is that historic houses are inefficient and obsolete. The Glermaglass Historic District's significance is tied to conservation history. The preservation and reuse of older buildings continues to benefit the environment because historic buildings often use passive strategies to regulate temperature, such as having thicker walls, operable windows, higher ceilings, more natural light sources, porches, and overhanging eaves, to name a few. Reuse also decreases energy use associated with the demolition and disposal of old materials and the transportation and manufacture of new building materials. Increased energy efficiency can be gained through updating heating systems and through insulation, especially of attics and walls and around windows and doors. Studies show that it takes decades for even the newest of green or so-called carbon neutral buildings to recover the carbon that is expended in their construction. Preservation is almost always the most sustainable path. We would like to thank Ellen Pope and the rest of the staff at Otsego 2000 for their assistance and guidance with this project, as well as our professor Cindy Falk and the rest of our historic preservation classmates. Thank you.
Are there any questions?
All right, you guys are all set. Thank you.
Thank you.
Up next, we have Ernest. Hello, how are you? If you want to get unmuted there and go ahead and share your screen.
All right. Hi.
There we go. Hi, how are you?
Pretty good. Let me share my screen. Okay. Share screen. Okay. Let's see. Okay. Can you see my video?
I can see your video.
Okay.
All right, so if you're ready to go, I will start the timer here and you have 10 minutes. You're all set.
Thank you. Concept of honorable politics is indeed a powerful one, where the focus is on integrity, collaboration, and the common good rather than partisan division. If politics were conducted in such a manner, it could lead to a more inclusive and productive political environment where policies are crafted with the well-being of all citizens in mind. Honorable politics characterized by ethical conduct and bipartisan cooperation can have a significant positive impact on various industries within the economy. Here are two examples. Infrastructure industry. Bipartisan support have been successful because infrastructure development often receives bipartisan support because it is seen as a critical investment item in the nation's future. Economic impact. The investment in infrastructure can lead to job creation, improved productivity, and long-term economic growth. It can stimulate the construction industry, boost manufacturing for materials, and enhance logistics and transportation services. Another industry is technology and innovation sector. Legislative environment, a political climate that values ethical practices and collaboration can foster a legislative environment conducive to innovation, growth, and investment. This can lead to increased investment in research and development, support in startups, and the growth of high-tech industries. It can also attract global talent, encouraging a more dynamic and competitive technology sector. Examples of countries with honorable politics. While no country is perfect, some nations are perceived to have a more collaborative political environment. For instance, countries like Germany have historically had coalition governments that require parties to work together to form a government and pass legislation. This can lead to a more consensus-driven approach to politics. However, it's important to note that each country's political culture is unique, and what worked in one nation may not be applicable in another. Cryptocurrency can potentially contribute to the concept of honorable politics by offering a level of transparency, efficiency, and inclusivity that differs from traditional fiat currency systems. Here's how. Transparency and accountability. Cryptocurrencies by their nature are built on blockchain technology, which provide a transparent and immutable ledger of transactions. Efficiency in transactions. Cryptocurrencies can facilitate faster and more efficient transactions compared to traditional banking systems. Inclusivity. Cryptocurrencies can offer financial services to unbanked or underbanked populations, potentially increasing financial inclusion. Control and decentralization. One of the fundamental differences between cryptocurrency and fiat currency is the decentralized nature of cryptocurrency. They are not controlled by a single entity or government, which means they can operate outside the control of central authorities. Impact on the economy. If cryptocurrency were widely adopted, the economy might see a shift towards more peer-to-peer transactions and potentially less reliant on traditional financial institutions. Government and people control. Well, government versus people control, sorry. The control of cryptocurrencies is a complex issue. While the decentralized nature of cryptocurrencies suggests that the people have more control, governments around the world are exploring ways to regulate digital assets to ensure financial stability. Now, this is very important because there have to be regulations, because that's how you keep everything transparent and open. Okay, any questions?
All right, thank you so much.
All right, so there's any questions, I answer questions, but that's enough, then that's
You're
it.
all set.
Yes, good. Thank you.
All right.
All right, thank you.
All right, Cody, you are up next. If you want to go ahead and share your screen if you're ready.
Yep, 1 second. Make sure everyone can see it.
Yep, I can see your screen there.
Okay, amazing. Thank you.
All right, I'm going to start the timer here. You have 10 minutes.
Okay. Hello, everyone. My name is Cody Silverman. I am a second-year PhD student in the Dr. Igor Lednev's lab. The title of my research is Decoding Smokeless Powder in GSR Fluorescence, DPA identified as key component. So I'm going to try to zoom in here so it's a little easier to see. There you go. Okay, so start off with a little introduction. So the Lednev lab has developed a novel two-step technique for the detection and identification of OGSR particles. This is organic gunshot residue. In this method, fast fluorescence mapping was first used to detect the potential OGSR particles on adhesive tape substrate. Then Raman spectroscopy, which is a vibrational spectroscopy method, was subsequently used to identify these discovered particles. This two-step method was successfully conducted using a single instrument demonstrating efficient detection and identification of OGSR particles. So, to optimize this novel two-step method for gunshot residue detection and identification, the luminophore present in gunshot residue must be known. Thus is the focus of my research I'll explain today. So why is this important? Well, GSR analyses are important to criminal justice because they can provide critical evidence to establish the guilt of a suspect in a shooting-related crime. Smokeless powder, which is a common type of propellant used in firearms, as well as GSR is a type of trace evidence that refers to the residual particles left on the hands, clothing, or surfaces post-firearm discharge. Currently, in forensic casework right now, the most common tool for analysis of inorganic gunshot residue is scanning electron microscopy, energy dispersive X-ray spectroscopy. But this technique is expensive, destructive, and time-consuming. In addition, the analysis of smokeless powder can be challenging because the formulation is protected by intellectual property laws. So the focus of my study combines preparative high-performance liquid chromatography, steady-state fluorescence, and liquid chromatography mass spectrometry to determine the characteristic luminophore responsible for the fluorescence of the smokeless powder and gunshot residue. So let's talk a little bit about my samples. So in this table presents 5 smokeless powder samples, 5 gunshot residue samples from 5 different ammunition types. So here we have ammunition from 3 different firearm manufacturers, from Winchester, from Remington, and from Federal, with different bullet types to explore different types of gunshot residue. And we as well compared this to 5 known standards that are common in smokeless powder to serve as a comparison. Okay, now jumping into the how the methods were conducted. So what I would do is I would take 5 particles, whether that be smokeless powder or gunshot residue. I'd add them to a glass vial, like pictured here. Then I would add 500 microliters of dichloromethane for extraction. And then I would mix this, store it in dark conditions overnight. Then I would extract an aliquot, usually about 20 microliters. And then I would bubble this with nitrogen to dryness. Then I would reconstitute this in 70 microliters of LCMS grade methanol. And then this solution would be used to inject first into our high performance liquid chromatography, which is a little image of it here. Then this preparative HPLC instrument will divide these solutions into fractions, and these fractions can be analyzed using fluorescence on our fluorometer pictured here. And lastly, the third step would be analyzing these fractions using quantitative time of flight, or QTOF, liquid chromatography mass spec. Now, it's a lot of sciencey terms. I'll try to explain it as I go in a little more in depth here. Okay, so this first figure that we're looking here is preparative HPLC. Now, you can think of HPLC as it's a chromatography method, which is just used to separate components. So basically what we're looking at here is we're looking at absorbance on the y-axis and time in minutes. And the job of preparative HPLC is to collect fractions about every half minute. And what you can see here is this peak here that is labeled at fraction 53 has the highest absorbance. This is what our target is. This is what we're looking for. So we collect this fraction for downstream analysis. Now, the one thing about HPLC is that, yes, it tells us that this fraction has the highest absorbance, but it doesn't actually tell us what's in it. And so we need to do some more analysis. So then we move on to what I call steady state fluorescence. Now, a little bit about fluorescence. Your first peak here is going to be your excitation peak, and your second peak is going to be the emission. Now, at this first is all of the fluorescence spectra averaged for the smokeless powder. In the middle here is the average gunshot residue. And at the bottom here are those 5 standards that I mentioned previously over here. Now, at first glance, you can see that the average smokeless powder in black and the average GSR in red is very similar to each other, as well as to the DPA, or diphenylamine, in the light blue color. And these are similar, but also very different than the other 4 standards below. And you actually can compare this by looking at the wavelength. So if I were to, let's say, draw an imaginary vertical line going down like this, you can see that they all pretty much line up at the highest peak right here at around 385 nanometers. And I can also do that with the second peak here for emission. And if I draw a vertical line here, you can see that they all line up about 420 nanometers. So from this fluorescence, it suggests that diphenylamine is likely responsible for the fluorescence of this average GSR and this average smokeless powder. But just to be sure, let's move on to the third tier of our analysis. The last step of the analysis is QTOF LCMS. So LC meaning the the chromatographic separation, separating components in a mixture. So here you have intensity on the y-axis and retention time in minutes. And if you look at just the diphenylamine at the bottom here, you can compare the retention time with this peak as well as these other two peaks. And you can see that they line up pretty nicely. At around 8.2 minutes is diphenylamine, which suggests that the average Gunter residue and the average Miller's powder probably also contain diphenylamine at the same retention time. But if that wasn't conclusive enough, we can actually move on to mass spectrometry, which compares components based on their mass. So what we can do is take the spectrum here and look at their mass. And it actually all have a mass to charge ratio of 170. This makes sense because diphenylamine also has a mass of 170. And this would continue to suggest that the main component found in Gunter residue and smokeless powder is also 170. So I know that I just threw a lot of science at you, but just to summarize. So the fluorescence spectra of HPLC purified fractions have an excitation lambda max of 385 and an emission lambda max of 420. Just as I said, when you draw this vertical line, this lines up at 385 and this lines up at 420. And the LCMS results have consistent retention time between values at the 8.2 minute mark. And this peak corresponds to the same precursor ion at a mass to charge ratio of 170, which is this line right here. So this three-pronged analysis suggests diphenylamine was responsible for the fluorescence of both smokeless powder and gunshot residue. This makes sense too because diphenylamine is a common stabilizer used, and our results suggest it survives combustion since it was found in both the smokeless powder and in gunshot residue before and after firing. So diphenylamine was found to be responsible for the fluorescence of smokeless powder and gunshot residue based on the preparative HPLC in phase 1, the steady state fluorescence in phase 2, and the QTOF LCMS in phase 3. And these results can help optimize our two-step method for gunshot residue detection and identification already used in our lab. I want to thank the National Institute of Justice for funding this project, and I'll see a few references here. I appreciate you all for listening, and I will take any questions if you have any.
All right, if there are no questions, you are all set. Thanks so much.
Thank you.
All right, so we have one more presenter today. Is Kayla here? I don't think I saw yet. Okay, we are a little bit ahead of schedule. Kayla is not scheduled to present until 3:10, so we will hang out a little bit. If you wanted to go back into the main room and choose another breakout room, they are still going on until about 3:20, so you are more than welcome to, like I said, go back to the main room, choose another breakout room and visit one of those sessions. I will be here for a little bit, just hanging out, waiting for Kayla, so you're also welcome to stay here if you'd like to. Hi, Kayla, are you there?
Hi, I can hear you.
Hi, we did run a little bit ahead of schedule today, so whenever you are ready, we're good to go. Just let me know when you're ready. Go ahead and share your screen, and then I will put a timer on for you.
Oh, okay. Appreciate that. Let me get my PDF open real quick. I'm sorry, just getting my
You're okay.
hearings really good. Okay. Should be able to see my presentation. Okay, cool.
Yep, I can see your screen there. I'm going to start a timer. You have 10 minutes, and whenever you're ready.
Awesome. Okay, well, hi, good afternoon. My name is Kayla Thompson, and I'm one of the data science students from SUNY Westbury. That's my professor who sponsored me, Dr. Renu Balyan. And today I'll be talking about understanding gun violence and community factors and coming at this from a data science approach or a data-driven approach. So basically, I wanted to start off talking about just some facts pertaining to gun violence in America, just so we can get a picture of the current state within the United States. So basically, this is data from the Pew Research Center based on 2021 CDC data. The biggest things that I wanted to highlight were the fact that more Americans died of gun-related injuries in 2021 than any other year on record, and suicides accounted for more than half of those gun deaths in 2021. So essentially, continuing with the facts, 8 in 10 US murders in 2021 involved a gun, and amongst teens and children, gun deaths rose 50% between 2019 and 2021. So it's definitely a prevalent issue. And the good news is with the provisional data that we have so far, the trends show that there's been a decline between 2021 and 2022, and the numbers actually fell even further in 2023. So it's good to know that the trends are downward, but there's still a lot of work to do. And I also wanted to highlight the relationship between gun violence and community demographics, just to paint the picture for where it came added from in my study. So basically, these are just some graphics that I wanted to show, point out. I'll just zoom in so you can see them nicely. This is how gun violence relates to different demographics. On the left, we have sex and race, and on the right, gun homicides versus poverty rates. But this is just taking a look at Chicago between 2019 and 2020. So you can see the kinds of relationships that exist between these, just an example, these example demographics. So basically that brought me to my research question. In looking at other studies, they tend to be specialized, right? Gun violence in cities, gun violence in low-income areas, gun violence and how it pertains to children. I essentially wanted to go a bit more high level with my study and take a look at not just cities, but counties across the United States. And not just one community level factor, but as many as possible. So that question that I came to was, can incidence of gun violence be predicted at the county level based only on these community level factors and demographics? So it's a big question, and the first step that I took to answering it was determining, well, I need data, right? So what I was able to use to gather and source my data was government websites, right? So the first website that I was able to download this data from was the USDA, the Department of Agriculture. They have freely downloadable data sets on income, poverty, education, unemployment, and many more. And from the Census Bureau, I was able to get age, sex, and race-related data. So that was a total of 5 data sets. And then for the gun violence data, I had to utilize the Gun Violence Archive, which is a nonprofit United States organization that posts freely available, freely downloadable gun violence data. So from them, I was able to get 4 years worth of data aggregated, all pertaining to gun violence. So over 239,000 observations from those 4 years. So basically, all of these data sets were combined to create one big data set with just under 4,000 values, and it had 40 columns, 40 features pertaining to all just community demographic data. In that big data set with the just under 4,000 values, there were 1,238 unique counties in 44 states, and I had to determine if this was an accurate enough representation of the United States, since there were 6 states missing, as well as DC. Just looking at the averages across the counties, I was able to confirm that it would be a good enough distribution to represent the United States for the purposes of this study. Then came the issue of multicollinearity. It's still pretty small, but this is just to highlight how many of the features that I had that were very correlated. For example, there tended to be high correlations between poverty and having a bachelor's degree, unemployment and poverty, income and having a bachelor's degree. So these, things that are interrelated, which we also see reflected in society, also came up in the data. So that was something to account for in modeling. And going into the modeling, I used the models that I decided to use were first the random forest classifier. So I just spoke about those high correlations and accounting for them. Random forest would take care of that. Generalized linear mixed effect models, because it could also take into account random effects due to socioeconomic and demographic factors in this kind of data. And lastly, the Keras sequential API, because I wanted to incorporate a deep learning perspective. So with this breakup of the data, 60% training, 20% to both testing and validation, I was able to use these features. These 8 features made it into the final model, and I didn't determine them. I had random forest feature importance to determine which features would be best used for modeling. So onto the analysis portion and the results that I got from running these models with this data. First off was the random forest classifier results. I got an accuracy of 64% on the model, which comparing to other studies that I've seen isn't so far off, but could absolutely be better. And this is the confusion matrix I got for that particular model. And I also wanted to include precision and recall because I felt like while accuracy was more important, these do have bearing on whether or not these kinds of models can be deployed in the real world. Similarly, for the generalized linear mixed effect, or GLMM, I used two different kinds of models, stats models, which was in Python, and GPBoost, which I used with R. And from those models, I found that these statistically significant features within this data set that had features that had relation to incidence of gun violence or poverty percentage and having a bachelor's degree or higher. Now, median household income has an asterisk because it was only found in one of the models to be statistically significant. Similarly, high variability. Looking for testing for this feature for county, only the GPBoost model found it to be to have high variability or influence in this data. And finally, with the Keras sequential model, I included the confusion matrix again. This one had a slightly lower accuracy, which was interesting because deep learning, I expected it to be slightly better than the traditional learning approach, but nonetheless, I think I have ways to hypothesize how the accuracy could be higher. Which brings me to conclusions on this very preliminary and very foundational study. Those three conclusions that I came to were the fact that community level factors do show relation to the incidence of gun violence, even if it is smaller in scale. And also predicting incidence of gun violence at a county level seems to be more reliable with the traditional machine learning approach as opposed to deep learning, although that's just one conclusion to come to with this data set. There's potential for variability of the gun violence incidence due to that county feature. Now, essentially, these results and these conclusions are very preliminary. What I was looking for future direction was to incorporate more of that GVA data that I mentioned in the beginning with the over 239,000 values, right? We brought it down to 4,000. What happened to the rest of the data? Well, since it was just a county level study, bringing it to maybe even a town level study, adding that extra layer of granularity would be able to improve the outcome of these models, improve the accuracies that we're seeing in these precision and recall scores. That's my next step in the future direction. And of course, maybe even looking at murders versus suicides, since I mentioned in the beginning, those have very different trends. So taking that approach to this study is also another avenue. But yes, these are just my references. And yes, that was all I had for this.
Thank you so much. All right, so do you have any questions for me? You're all set.
Sorry. Yeah, no, I'm all set. I've got it,
Sounds
right?
good. Yep, you're good to go. Thank you so much.
Thank you. I appreciate it. Have a good one.
You too.